So, good morning, everyone, and thank you for coming, and thanks for the invitation. Um, a little bit about myself. My name is Chen. I come from China. I'm actually currently working in design to production, and today I'm going to present the company Design to Production. And it is a company founded in 2007 by Fabian Schorer and Arnold Watts. We have a main office in Zurich and also a branch office in Stuttgart. And we support architects, engineers, and fabricators to solve complexity problems in their projects that they cannot solve. So for over 10 years, we have worked with more than 60 projects, and most of them are long-standard structured timber structures, and they are doubly curved structures. And also we do software design development for some clients for fabrication use. And what do we do exactly in these projects? Actually, design to production is doing neither design nor production, but we try to do the two. So we try to communicate in a higher level between design and production. And we bridge the gap between digital design and digital fabrication. So if you look at this diagram, we try to integrate design, planning, and fabrication from what we learned from them and try to put them into a digital model as a kind of information repository so that we can process the information and hand out information into different parties. What we do specifically is design optimization and design for manufacture assembly and digital fabrication management. So today I'm going to show, I choose a small project, and then I can have time to present the principle behind the project so you can get a better understanding of our principles. So this project is Eddie the Skier. It's a ski sculpture for Ski World Championship, which took place last year in St. Moritz, Switzerland. The client is Aroma Production. It's a big agency who is hosting the event. And the challenge for us is that we entered this project in a quite late phase, where we have only 15 weeks to finish the planning and building. I think we had the kickoff meeting in October, and we have to finish our job in December. And the production happened over the Christmas, and the assembly is finished in January. So it's a small project, but it's still complex in a certain degree. We have over 600 panels, thanks to the architects. And between each panels, they form different angles, which result in the end, over 900 different angles, and also over 300 nodes, where you have extreme points that can be 14 panels come to 1 point, which is really complex. This can be solved actually in the earlier stage, but we entered it quite late. So our role was to actually mainly focus on planning and fabrication, because the design is more or less fixed. And what we do specifically is to do the detailing and to do the digital fabrication management. Yeah. So the first of all, we have to think about the connection details. As you can see, we have to deal with over 900 connect edges because they have different angles. What we do is that since the connection is on the back side of the panel, so we can just have a very simple connector beam to connect two panels. But since we have different panels, which anyways will be CNC-cutted, we try to rationalize the connector beam into 10 standard types, where they have 10 different angles. but we try to fine-tune the panels by cutting the edge of the panel to match this 10 type of connectors. So according to this detail, we transferred our design model into our production model, where we embed some extra meta information, including the numbering of the panel, the size of the panel, some other production information like the cutting paths and mounting marks, etc. And these panels and this model will be later translated into the machine, the fabricator side, where we nested the panels into 72 boards. Then this data is later translated into the machine language, the machine code, where the fabricators can do the 5-axis CNC manufacturing directly from our model without further processing data by themselves or without adding joins. Yeah. So after we fabricate all the panels, we actually engraved the numbers on the back side of the panel. And in addition, we put the A4 page paper and including the information such as geometry information, the length, the connection angle for this panel, which you can do quality control later. And also we put the assembly information, such as which connector beam you put next to it and which panel is also next to it. By this, the construction team actually can just assemble the panels without any additional information. Just the information we provided would be enough. And then they combined the small panels into bigger elements. As you can see, it's a shoe here. And this 22, so from 600 something panels, they combined into the 22 bigger elements and then transported them into the site. And then finished assembly in 3 weeks on site. So this is the result. As you can see, the edges are still sharp and the corners are still pointy. So talking about the principles behind the project, first of all, what we do and what we always try to do in any project is that we do prefabrication. We try to get complexity away from the building site and put it actually into the workshop and also put into the parts. And these parts is already defining the geometry and assembly information. So the assembly can happen partly already in the workshop, so they can spend as little time as possible in the -10-degree construction site. One of our role model is IKEA, because they constantly try to make parts fewer and make the details smarter. They try to integrate somehow, for example, connection details and functions into the geometry already. So when you do assembly, it's basically foolproof. For instance, they drill the holes with different diameters for different types of screws. So the users, when they assemble it, they don't mix up the screws basically, and it's pretty simple. And this rule also applies for our industry, except that we do have a few more components, customized components. But if you look back into the detail that I mentioned before, we do have a simple connection, but this connection is smart enough, so you can assemble it without any badgering, and it's pretty simple, but still you can achieve a precision and quality like we have in the left. The reason we can achieve this is because we think about details and assembly in the very first position, in the planning stage. That means, normally in the production process or in the industrial process, you always do planning first, then production, and then assembly. And we try to introduce the pre-assembly in assembly phase, where you put these two boxes, smaller, sorry, and shift the complexity. Sorry. Yeah, probably. Sorry, my throat. No. Yeah, we try to shift the complexity from the assembly process, from the assembly phase to our planning phase. Thank you very much. But you can see, at this point, we try to keep the production the same. That means in our mass production or a mass customization, we need to keep a systematic approach where all our 600 panels should follow the same rule and they should follow the same fabrication strategy so that you don't waste time or waste money and get individual parts still with a zero cost. And of course, this needs digital fabrication because we do have machines that doesn't care about producing 1,000 same piece or 1,000 similar pieces because they do cost the same. And this also needs at this point you realize that you need actually parametric model because you don't model 1,000 pieces manually, otherwise you waste the time you just put the time in the planning phase. So it's really important for us to keep the model parametricized, and we try to program instead of drawing or modeling so that our model is always fluid and it's not frozen. Whenever you need more input or output, the model can always interact with it. And this brings us to the last question. Until now, we have only changed our tools, but still most of the people in our industry haven't changed the thinking model. So if they get an input and they always try to create their own models and throw away half of the information from the earlier stage, and what we try to now do and what this hackathon tries to do is trying to change the mind or the mindset of the whole workflow. And I hope probably in this hackathon we can see something very inspirational. And that's it. Thank you.